Today we are going to solve the questions from the chapter Aromatic Hydrocarbon. Actually, these questions are asked in your NEB board exams. The first question is, what are aromatic compound according to Huckel's rule? So let's write down the answer. According to Huckel's rule, the cyclic planar organic compound containing delocalized ON plus 2 pi electrons where n equal to 0, 1, 2, 3 etc. are aromatic compounds. So this is the answer. We have to write down the example here. Now one or two examples. The first example is, examples that follow Huckel's rule is, first of all, the benzene, okay. There are 3 pi bonds, we can see. So actually 1 pi bond equal to 2 electron, that means 3 pi bond equal to 2 electron, that means 3 into 2 gives 6 pi electrons. So we can now use the formula for that. 4n plus 2 equal to 6, so 4n equal to 4, therefore n equal to 1. So this is the calculations. So we can see that benzene is aromatic compound according to the Huckel's rule, because it has the value the n equal to 1. Now we can add another example as well here, but this is the very short questions. You can just write down one example or 2 examples for these questions. So now let us solve the question number 2. Question number 2. So what is our questions here? First of all, look at here. Why is benzene called aromatic compound according to Huckel's rule? अब बेन्जिनलाई चाहिँ किन एरोमेटिक भनिन्छ भन्ने क्वेशन सोधेको छ. त्यसको लागि आन्सर छ, because I am writing this a very short format, because benzene contains delocalized 6 pi electron. We can see here 6 pi electron that we calculated from here. 6 pi electron, that is the value of n equal to 1, because the benzene contains delocalized 6 pi electrons, n equal to 1. That is, it follow Huckel's rule of aromaticity. You can say, if it contains delocalized 6 pi electron, then if it has the value n equal to 1, then we can say that it follow the Huckel's rule of aromaticity, that is the 4n plus 2 pi rule, or we can write down this rule. So you have to show the calculation here for this question as well. So you can see the calculations in the previous question. So let's calculate the value here again. This is the 2 marks question. So you have to show why it contains 6 pi electron, why it has a value n equal to 1, and you have to use the formula to prove this. So pi, 3 pi bonds, this is the benzene ring, and this means 3 pi into 2 electron equal to 6 pi electron. Now show the calculations according to the Huckel's formula. 1 plus 2 equal to 6, 4n equal to 4, therefore n equal to 1, hence proved. So this is the answer to the question number 2. Now in question number 3, we have asked that write the resonance hybrid structure of arene containing meta detector and orthopara detector substituents of each. So for this questions, okay, first of all, for the benzene containing orthopara director substituent, यसको लागि चाहिँ हामीले एरोमेटिक रिङ फर्स्टमा बनाउने. अब हामीलाई अर्थोपारा ग्रुपहरू कुन कुन हो भन्ने कुरा थाहा हुनुपर्छ. यसको लागि हामीले रेजोनेन्स हाइब्रिड बनाउँदाखेरि यो चाहिँ ड्यास लाइनले रिप्रेजेन्ट गर्नु चाहिँ बेटर हुन्छ. सो यसको लागि पनि ड्यास लाइन यहाँ OH राखौँ, डेल्टा प्लस डेल्टा माइनस डेल्टा माइनस डेल्टा माइनस. दिस इज द रेजोनेन्स हाइब्रिड of the phenol. So similarly in the question number 3, you have asked that how you have to write down here for the meta detector as well. So for the benzene containing M director substituent, so nitro group is a very popular example for this one. Nitro group is a meta detector group. For meta detector group, minus in the NO2 group and plus in the orthopara positions. So what is the difference between these two structures? यहाँ हेऱ्यो भनेदेखि OH मा प्लस चार्ज छ, NO2 मा माइनस चार्ज छ. यहाँ हेऱ्यो भने अर्थो र पारामा पोजिटिभ चार्ज, यहाँ हेऱ्यो भने अर्थो र पारामा नेगेटिभ चार्ज. सो दिस इज द डिफरेन्स बिट्विन द रेजोनेन्स हाइब्रिड स्ट्रक्चर अफ अर्थोपारा डिरेक्टर एन्ड द मेटा डिरेक्टर सब्स्टिट्युएन्ट्स. सो अब यसले चाहिँ के देखाउँछ भन्दाखेरि यो रेजोनेन्स हाइब्रिडले चाहिँ यो बेन्जिन रिङमा इलेक्ट्रोन जुन डोनेटिङ ग्रुपहरू हुन्छ त्यसले अर्थोपारा डिरेक्टरको काम गर्छ. यो इलेक्ट्रोन डोनेटिङ ग्रुप्सहरूले डोनेट गरेपछि यहाँ प्लस चार्ज आउँछ र यो इलेक्ट्रोन डेन्सिटी एट अर्थो एन्ड पारा पोजिसन चाहिँ के हुन्छ त इन्क्रिज हुन्छ. त्यस्तै गरी NO2 चाहिँ विथड्रइङ ग्रुप भएको हुनाले इलेक्ट्रोन विथड्रइङ ग्रुप भएको हुनाले यसले चाहिँ इलेक्ट्रोन विथड्र गर्छ बेन्जिनबाट. त्यसै कारणले यसले इलेक्ट्रोन डेन्सिटीलाई चाहिँ अर्थो र पारामा डिक्रिज गराउँछ इन कम्पेरिजन टु द मेटा पोजिसन्स. अब यहाँ पनि हेर्न सकिन्छ हामी इन कम्पेरिजन टु द अर्थो र पारा पोजिसन्स, मेटा पोजिसन्स एज द लेस इलेक्ट्रोन डेन्स भनेर भन्न सकिन्छ. डेन्सिटी चाहिँ कम छ भन्न सकिन्छ. त्यही भएर अब आउने इलेक्ट्रोफाइलले यसलाई कहाँ एट्याक गर्छ त अर्थो र पारामा एट्याक गर्छ भने यसमा चाहिँ मेटामा एट्याक गर्छ. यहाँ मेटामा चाहिँ नेगेटिभ चार्ज छैन तर पनि पोजिटिभ चार्ज पनि डेभलप नभएको हुनाले यो पोजिसन चाहिँ इलेक्ट्रोफाइलको लागि चाहिँ सुइटेबल साइट भयो एट्याक गर्नको लागि. सो दिस इज हाउ वी क्यान राइट डाउन द एन्सर टु द क्वेसन नम्बर 3. Now question number 4. Question number 4 is what happens when sodium benzoate is heated with soda lime. Okay, the structure of sodium benzoate is COONA and it is heated with soda lime, means the mixture of NaOH plus COO, which is called the soda lime. This mixture is called soda lime and when it is heated with soda lime, then benzene is produced. So this is sodium benzoate, this is benzene along with Na2CO3 is the byproduct, and this CO is used here to absorb the water molecules or to make the NaOH in a dry conditions. The next question is the phenol is heated with zinc dust. Now the next questions, phenol is heated with zinc dust, so answer is, this is the structure of phenol, and when it is heated with zinc dust gives benzene along with zinc oxide. This hydrogen is, we can write down the hydrogen here, and there are the other 5 hydrogen attached to the carbon, so we have not shown here the hydrogen. This is the phenol, this is benzene. Similarly, the next question about the benzene is used acetic anhydride in the presence of anhydrous AlCl3. So third, benzene is heated with acetic anhydride. Acetic anhydride means CS3 C double bond O CO CS3. This is acetic anhydride or ethanoic anhydride. This is benzene. When it is heated with in the presence of AlCl3, then it produces acetophenone, and this is the Friedel-Crafts acylation reaction, and the byproduct is CS3COOH. Okay, our next fourth question is, this is acetophenone, and this is acetic acid, or we can say ethanoic acid, acetic acid. The next question is, benzene is heated with hydrogen in the presence of nickel powder. So that means this is the reduction reaction. When benzene is heated with hydrogen in the presence of nickel powder, then cyclohexane is formed. This is benzene, this is cyclohexane. So similarly, question number 5. Question number 5 is benzene is treated with chlorine in presence of sunlight. We have to look at it. This is the sunlight. Sometimes FeCl3 is given, sometimes sunlight is given. So benzene, when treated with chlorine in the presence of sunlight, then the chlorine is added and this is the BHCl benzene hexachloride. This is benzene. If sunlight is used, and then you have to write down the product BHC. If FeCl3 is given, then make only the chlorobenzene here. And in this reaction, in the fourth reaction, there are 3 double bonds, pi bonds. So altogether 3 hydrogen or 6 hydrogen necessary in order to make this cyclohexane as a product. This is the addition reaction. Now let us look at another questions. Benzene is heated with Conc SNO3 in the presence of Conc H2SO4 at 60 degrees Celsius. So the next question is, benzene is heated with concentrated HNO3. concentrated in the presence of conc H2SO4, and here we have the electrophile NO2 plus the nitronium ion. Therefore the product is nitrobenzene. This is the nitration of benzene or electrophilic substitution reactions. So another questions. Now we have at 60 degree, that means here the temperature is very crucial for this reaction. Above 60 degree metadinitrobenzene or 135 trinitrobenzene may be produced, and the temperature, if 60 degree, around the 60 degree temperature, then we have to write down the mono substituted product. If above 60 degree is given, for example 80 degree Celsius is given, then we have to make a meta substituted derivative dinitrobenzene. If 100 degree, around 100 degree is given, then you have to make 135 trinitrobenzene as a product. So let's look at the another questions. Acetylene gas is passed into the heated iron or copper tube. So this reaction is the aromatization reaction or the cyclization reactions. So we have CH triple one CH. So red hot copper or iron tube. So 3 moles of ethane or acetylene is required. Then benzene is formed. We can write down like this. Here 3 double bonds. This is benzene, or you can simply write down, when acetylene gas is heated or passed through the red hot copper tube or iron tube around 450 or above that, then benzene is formed. So the product we can write down like this or like this. So another questions. Chlorobenzene is treated with nickel aluminum alloy in presence of NaOH. Okay, let's write down. So chlorobenzene, this is also a reduction reactions. When haloarine reduced in the presence of this nickel aluminum alloy in presence of NaOH, this NaOH reacts with aluminum to produce nascent hydrogen. Then this chlorobenzene is reduced to produce the benzene plus hydrochloric acid, and this hydrochloric acid is neutralized by the NaOH in the medium to produce NaCl and water. So we don't have to write down that. Now next question is about benzene is heated with chlorine gas in presence of Lewis acid. So what is Lewis acid? Is AlCl3 or FeCl3 or FeVr3 or BF3, like that. The Lewis acids are the electron deficient compound, or we can see that the central atom has does not follow the octet rule, that are called Lewis acids. So the next question is about the benzene heated with chlorine in the presence of Lewis acid. So let's say AlCl3, then chlorobenzene is produced. Here is the chlorobenzene, this is benzene, this is chlorobenzene, and a monosubstituted product is formed after this reaction. And this is also the electrophilic substitution reaction. Here the electrophile is chloronium ion, and in this reaction, this is the free radical addition reaction, we can say. In the presence of sunlight, 6 chlorine are added and the double bond is removed from there. So this is the addition reactions, whereas this is the substitution product, and this chloronium ion actual electrophile where this hydrogen is substituted in the benzene. So this is how we can solve the questions. Okay, answer to the question number 8. Here we have to identify X and Y in the following sequence of the reactions with their Hydrocarbon names. So first, chlorobenzene reducing agent. Here there is a reduction reaction. X is formed, and X, when treated with CS3Cl in the AlCl3, Y is formed. So this is our hint for the reaction to find out X and Y, because there is no any clue here, only this is the clue for us. So the first answer to the first question, 8.1, is the structure of chlorobenzene, this one, and LiAlS4 acts as a reducing agent which reduces, and HCl is released from here, so thereby forming benzene. So benzene is our product X, and when it is treated with CS3Cl AlCl3, then Y is produced, then that is toluene. Over here we can see this is the benzene to toluene, means their CS3Cl and AlCl3 means this pair results in the formation of methyl carbocation, and this is the Frederik alkylation reaction. So there is a formation of toluene is the product Y, and this starting compound is chlorobenzene. So now question number 2, some sodium benzoate. You can see here sodium benzoate, soda lime heated, XCl2 light. This is the similar to the previous one. We have already solved this type of questions. COONA. So soda lime means the mixture of NaOH plus CaO. When it is heated, produce X here. So produce X. X means here benzene. This is the decarboxylation reaction. Here benzene is X. Sodium benzoate, and when it is treated with the chlorine in the presence of sunlight, then BHC is produced. This is benzene hexachloride or BHC. This is the product Y. Okay, now the next to the last questions from the aromatic hydrocarbon sections. The question is, you can see here zinc. X treated with zinc, dust, benzene, and here the CS3COCl means this is the acylating reagent. Obviously from benzene to Y we can easily write down here product. So let's write down. Here is a benzene is given in the middle, so benzene, and then CS3COCl AlCl3 is given, means that means obviously this is the acetophenol Frederik acylation reaction. This is the product Y here. Now, and this benzene is produced by heating the zinc dust. That means obviously the starting compound must be phenol. That means this is X. Third questions. So this is how we can solve the questions from the aromatic hydrocarbon chapter. In the next sessions we are going to discuss about the haloalkane chapters, including chloroform and the monohaloalkane. Now we are going to solve that.